So we ended last time thinking about reversing a vector or an array. Okay, we came up with the idea. We came up with the everything we need to do. We listed out. It's just a bunch of swaps. First the first thing and the last thing, then the second thing, second to last thing, and just work your way inward. And the number of swappings that you need to do is always your size over 2. Okay, is that coming back to us? So that's what we're going to implement this time at the very beginning. All right, so we're going to need to iterate. We're going to need to iterate and exactly this many times, size over 2 times. Okay, so that's like the first thing. And we'll use our iteration variable. We'll keep track of like the left side of all the stuff that we're swapping. So here, let's make a new file called reverse. There, reverse, and let me make a vector. And doesn't have to be in order, but I'll make one in order. Why not? And so what I'm going to do is I am going to make a loop. I'm going to loop exactly size over 2 times, right? Because that's how many times I need to do this kind of swapping. So I'm going to loop size over 2 times, and I'll start an I variable at 0. All right. So for int I equals 0, I is less than v dot size. It knows its size over 2. Okay. I plus plus. And so this loop will iterate exactly size over 2 times. That's great. And then I, this variable I, it's useful to start it at 0 because that's always the left side, right? And that's always the left index that I want to be swapping with each iteration. First it'll be 0, then it'll be 1. It'll work its way slowly but surely. I just need to come up with this one each time, right? I want to calculate the other side. So that's going to be the game, right? So it's always each round of the loop, swap your I with, swap your I with size minus 1 minus I will be the answer. All right, let's try and look at this. So here's the vector that I just made. It's got 7 things. All right, 0, 1, 2, 3, 4, 5, 6. All right, so I'm setting my I variable. It will start off, I want it to loop 7 over 2 times, right? So that's 3 times only. And so I want I to range then from 0 to 2. Starts at 0, that's this index, right? And I want to swap it with index 6. How can I calculate that using this 0 that I have here? It's going to be size minus 1, always minus I, right? See how that's always going to work out? That'll swap these two, 0 and 7 minus 1 minus 0. So that's 6. That's the first round. Then the next round when I is 1, it'll swap index 1 with what? Size minus 1, so 7 minus 1, so 6 minus I, 5. See, that always is going to give me the right-hand side there. Now it's the math. That's the trick, right? And then the last time when I is 2, it's going to swap index 2 with index 4. Right? And then I'll calculate it by size minus 1 minus I. So we've got 6 minus 2, which is 4. Right? So that's how that's going to work, and it will always work regardless of the length. Okay? Odd or even. And so yeah, we're doing that integer division. Remember, that's going to give us just 3, not like 3.5 iterations. Okay? So that's what we're going to do. Let's kind of code that up now. So I've got I. What do I want to do with I now? I would like to start swapping stuff. All right? So remember my swapping algorithm. Let's go back to like, if I was 0, right? If I was 0, let's pretend we're right there. I need to make like a temp variable, right? And then shove the 1 into there. Then I can replace those indices. Now that can be 7, and that's going to be temp again. That's what I got to do. The shuffling that needs to happen. So let's make that work. All right, so swap indices I and size minus 1 minus I. Okay. So just for fun, let's just like store this index in a variable, just like we have I in a variable. I'll call it index to swap with. Why not? That's v.size minus 1 minus I. And so I want to swap index I with index to swap with. Yeah. So all right, here's the game. Int temp equals the first thing, v at I. And then it's always the last thing on the previous line becomes the first thing on the next line. So v at I, now I can set that to v at the other index to swap with. And then now this becomes the first thing on the next line, v at that last index, right, needs to become the thing that was in index I, which I saved carefully away in the temp variable, okay? And so yeah, that's going to swap them all each time, and by the time it's done, I will have a reversed array for vector, I guess. So let's go through it. For every E in V, please output that E range-based for loop. Let's look at the fruit of our labor. All right, so there it is. It used to be that, and now it's not. It all got reversed, and this will work regardless of the size of this vector. If I made it size 6, it's still going to work. Still even size is fine. It'll swap the right amount of times. Questions about this? Doesn't matter. 6, 7, 5. It's just all the elements because of the way that we're swapping them. It's going to work. It's going to go to those indices. We're not even talking about numbers. We're just talking about indices. You see? So it will always work. Yeah. Other questions? It's a fun algorithm. We kind of came up with that, right? We came up with it together. That's pretty cool. All right. So now I've taught you a lot of stuff. I've taught you about vectors. I've taught you about arrays. Remember those. Go back to the notes. Go back to the code from class. I have a question for us to get started. All right. Please get into peer instruction groups, and I'll stop attendance after we finish this question, so make sure to do it. And go to that written ice page, please. You can elect the leader of your group, but what I'd like you to post is write down how to do the following, right? For both arrays and for vectors, right? Show me how to do each. How do you access an element at a given index for an array and for a vector? Okay, see if you can figure that out. How do you initialize an array to hold 1, then 2, then 3? And the same for a vector. It's different, right? And then finally, how would you create a brand new array or vector of size 10 holding 42 in every index? I know that's going to be like a longer loop, so just like write how you would do it in English. I'm going to declare this, and then I'll use a loop iterating this many times and do this, something like that. So yeah, does the question make sense? They're different things, so see if you can explain in your own words like how to do each. All right? For all but these, I want the code though. For all but that one. So help each other discuss. Another minute or so. that making sense? We're quieting down, it sounds like. Another few seconds to click the submit button. Alright, let's see what we're thinking. See how we do all these things. Yeah, remember that's good. It's the brackets for array accesses. That's totally one way to make it all 42s. That works. Nice. Pushback would be the easier way for a vector, though. Very, very nice. How would you go to an index? It's the brackets or the dot at. Nice, nice, nice. So thank you, those of you who click submit. I appreciate it. All right, and I promise to stop that. Whee. So yeah, that's right. So let's spell this out. How do you access an element at an index? So if you got an array, you can give it any name, but these brackets are of I. We'll do it for an array. For a vector, it's the dot at, just like for strings. All right. To initialize to hold 1, 2, 3, that would be the easy way would be the int r bracket bracket equals 1, 2, 3. You don't need to put any numbers within the brackets if you're given the things, but you could if you wanted to. It's like, okay, it's 3 as well, but that's unnecessary. And then for vectors, you could do, right, vector int v equals 1, 2, 3, very similar to the array syntax, or you'd be like vector v semicolon, and you could have like pushed back a bunch of times, v.pushback, because that's an operation that vectors support. Pushback. Just like those 3 values, one after the other. And that's one way you could do also this, right? How do we do this? Well, I guess the easiest way for an array is just like spell it all out, I guess. 42, 42, 42. Or you could just make like R10 semicolon in a loop, go to each index. That's totally fine. I feel like that's probably the quickest way is to just write it all out, honestly. Vectors, you have options. You can do the pushback, like I saw some of you doing in your responses of good. There's actually a secret way to fill up a vector very quickly. It's called a fill constructor. I don't know if your book is ever going to say this, but if you say vector int and you declare and you give its name and you don't put a semicolon yet, but you kind of call its name as a function, you can say, I would like you to be filled with 10 42s, please. And just do it in one line. It'll do it for you. That's kind of cool. All right, so yeah, I hope that makes sense. Any questions about that? All right, so let's talk about a different kind of string now. It's called a C string. And we've been using the string type in the string library, and that's from the C++ language. There's an older version of strings that were used in the language before C++, the one that it is based on, called C. So the string type, those are C++ strings. There's a C string though, right? So here is what a C string is all about. All right. We would prefer though, if you can, always use a C++ string. There are certain places where you're forced to use the C string thing, and that's why I'm teaching it to you. It's also a good practice for arrays because it's a special kind of array, right? So a C string is a special kind of character array. That's what they used in the Stone Ages, okay? So the type of a C string, it's not string anymore. It looks like this. It's like char bracket bracket. It's like an array of characters, if that makes sense. You will also see this. This is equivalent to this type, char and then star. That's another name for a C string. Two equivalent types, which I can't explain to you why they're equivalent just yet. Wait a few more weeks and I will, I promise. But you see either one of these, that means C string, right? An array of characters, or char star even, all right? And it's a special kind of character. So this, while a character of strings that spells out hello, is not a C string, all right? There's a special thing that's needed in every character array to make it a C string. It's this thing. If you include this \0 character, that creates a C string. It's got a mark at the end of it, all right? So this marks the end of the C string. Because you remember that arrays don't know their size. This is a cute way to always know when the string is over, when I don't have to go any further into indices. All And then everybody decided like this is dumb to write it like this. So actually, every time you use double quotes in C++ even, you are making a C string. It's shorthand. This is exactly equivalent to that. Isn't that interesting? So every time you made an actual C++ string, it was converting a C string secretly. So that's weird to think about maybe. But yeah, this syntax is exactly the same as this because nobody wants to write it out. And then also include the \0. This is going to do it all for you. Right? This makes a C string. And the \0 is called the null terminator character. Right? 0 for nullness, I guess. That's another name for that. For nothing. And it just marks the end. Right? Just tells you when it's done. So every string that you make, like these guys do, those two, in memory, they're going to look like this. Right? It's just an array of characters, but it's got a special last character. H-E-L-L-O in that. So H-E-L-L-O, and then null terminator character, and that's just how that works, right? So \0 is our null terminator character that needs to exist and mark the end of every C string. And if you make a C string, C++ knows how to work with it still. You can shove it to C out, and it's happy. Doesn't matter. So let me show that to you. Character array. So let's make a couple strings, C strings. So char s bracket bracket equals H, then E, then L, then L, then O, and then the \0 character. All right. So that is a C string. Oops, my editor is being weird. So that is a C string. And then everybody hated doing that, and so they made this shorthand, right? S2 double quotes means C string secretly. This is exactly equivalent, it's just a different, instead of SSS2. All right, this is shorthand for the above. So those are both valid C strings, and you can give either of them to C out, and it's happy. Boop. So there it goes, and it prints hello. It's fine. You can do the same with S. All right. So does that make enough sense so far? Just an array. Yes. That's just how I want you to remember it. That's this weird name. All right. There's a whole bunch of functions on C strings because everybody used those in the C language. So there's a C string library. All right. There's also something from the cstdlib library as well that I'll show you. But both of those, you can go and you can look at nice functions on C strings. So let's go to both of those. So it's from the C library. We got cstdlib and then C string. They're right next to each other. Nice. So here's a bunch of stuff you could do. Some of these are for C strings, like this one, A2I. We're going to get to that one. And then some other C string ones. You just scroll down. Feel free to look into that. All right. So let's see what I want to do first. Let's do the one in cstdlib first, because that's like the odd one out. So let's talk about A2I. All right. So this is a function. If I click on it, A2I. It takes a C string, see the char string, and it gives you back the integer form of it. Because sometimes you might have a string that encodes numbers, right? You might have the string with a bunch of numbers in it. That's not a number yet. Remember the difference between quotes 4 and the number 4? There's a whole giant difference, isn't there? So A2I is going to take your C string and convert it to a number if it really was a number, okay? Because you can't do math on it yet. It's just characters before that. All right, that's A2I, and it lives in the cstdlib library. So let me just include both while I'm up here. That's where A2I lives, and then some other ones will be in C string. So I'll just include that right now. All right, so let me make another character array, char s3 bracket bracket. Let's make this C string, 42. All right, so this is the string 42, the C string 42. I can't do math with it yet. If I would like to convert it to the int that it really is and do math with it, I will use the A2I function. Give the string to A2I, and then I can do math. I can like multiply it by 2 or whatever. And then I really will get my 84. Okay? Does that make sense? The difference between the C string 42, those just characters 42, meaningless, versus, okay, make that an integer so I can do integer things with it. Key difference. There's a type difference there. All right? So that's that. There's also a in the C++ string library, there's an S2I function that kind of takes over this. It will convert a C string as well. So you could just like remember S2I. And it works for everybody. So that also works. But yeah, let me show you some more. So they're a little weird because they're like from the older language, and so they got weird names. Everybody loved 6-letter max functions in the C language, so this is what these are all looking like. Let's talk about strcat first. It's short for string concatenate. All right, so let's go and look at that. That's in the C string library. Where is that? Strcat. Here it is. So it's a little weird. It takes 2 C strings, a destination and a source, and just like tacks on this, the second one at the end of the first one, which is weird, and then it also returns the string back to you if you wanted it. So here is, it's better to show it to you with an example. So if you call strcat on 2 C strings, like S1 and S2, then what it's going to do is that's kind of equivalent to the following. Oops. In C++ string land, it's equivalent to being like S1 equals S1 plus S2. You can't do that in C strings, but this is kind of doing that instead, right? Let me show that to you. Let's make some C strings. And because it does this though, right, it's going to tack on S2 to the end of S1. You better have extra room at the end of S1 because it's just an array. Yeah, you better make extra space and don't fill it up completely because otherwise it's going to do weird stuff. Adding characters to the end of an array secretly. All right, so let's make some more C strings. S4 is high space, and then char S5 is mom exclamation point. So I cannot say strcat right now on S4 and S5 because it's going to do this, right? S4 equals S4 plus S5. This will not work because there is no room at the end of S4 right now. It will write to arbitrary memory that is not good. All right. So to give us some extra space at the end of high, I can do the following. This is actually the one time you might want to do this. Let me give and make sure that S4 is 50 characters long. All right. And I just wanted to start it off with this. This will fill in the first 1, 2, 3, 4 characters for the null terminator. And just everything after that is undefined. Right. But there's space now to be filled in. And so now there's room. And if I call this, it will tack on mom at the end of S4 as well as the null terminator character. Right? And so this will turn S4 into the following. The H character, then the I character, then the space character. Those are all still there. And then right after that, it placed M, then O, then M, and then an exclamation point, and then the null terminator. So that's the new, that is what is in S4 right now. Everything after that, there's 50 characters. I could have done this better, but all the rest is garbage still. All right, so that's what's going to happen there. And so let's code that up. So now, if I see out S4, I should see hi mom all together. It's one big string now. Cool. So it's a little weird, but you might need that one day. All right. Here's an easy one. Strlen. Yeah. That is going to go and look for the size of that C string, which technically you could do yourself now. You could loop through, go looking for that null terminator character, huh? But let's go look for that. That is strlen. There it is, way down there. Takes the C string, gives you back its size in some integer-ish type, right? And it's going to give you the number of actual characters in the string, so it's not going to count the null terminator. So keep that in mind. All right. Returns the size of the actual characters in it. All right. So let's get the size of this S2 string. Hello. See out strlen of S2, and this is print what? It says the length of S2 is 5, and so it's not counting the null terminator characters. So it really is taking up 6 characters of space, but it's saying it's 5 real characters, if that makes sense, right? So that's what it's going to say. It's going to tell you that amount. And yeah, so that's strlen. I think the last one I want to show you is a weird one. This is strcomp. It is short for string compare. It compares 2 strings in a disgusting way. So this is the weirdest one probably. I'll give you plenty of examples, but strcomp takes 2 strings that you want to compare against each other, and it doesn't return a bool like one's less than the other or something. It returns back to you an integer, all right? And so it's a little disgusting. What it's going to return depends on the following. If it returns a negative value, any negative value, that means that the first string comes before the second string. If it gives you back 0, that means the two strings are equal. And if it gives you back a positive number, that means that the second string, wait a second, that means, yeah, that the first string is bigger than the second string, okay? An example will help that make sense, but yeah, it's a little weird. So you're comparing against 0, actually, if you want it to be equal. Interesting. So, okay, before I do that, what else did I do? Oh, actually, yeah, before we even get into that, let me just show you kind of what in memory this line did, if that was confusing. S4, I said S4 of size 50, right? That is an S, that is a 4. Of size 50, so it got this many characters in it, right? Started at 0 all the way to index 49. There's a lot of extra space here, but I filled it in with just high space. And so what happened on that line was all right, it put an H there, put an I here, and then it put, it was a space, right? A space there. And then it also finished off the C string, so at index 3 it put an alternator. And then everything else was garbage. But there was empty room now. That's what happened on that line. So yeah, hopefully that makes more sense. So yeah, let's do string compare now. It's a little weird. So okay, let me show you what's going to happen. So it's going to return a number to you. Okay, so here's kind of the idea. It's going to go, and if S1 is less than S2, it's going to give you back a negative value, which is very odd to think about. But it's going to compare in dictionary order. Here's kind of the idea. Here's kind of the reason it returns a negative value. So say, for example, that we gave as S1 AAA, and as S2 is like AAB. What it's going to do, honestly, deep down, is it's looking at each character. It's like a dictionary. It's like, okay, which one would come before the other in the dictionary? So we'll line up those two characters and like subtract them. Oh, they're the same. All right. That is unhelpful. Let's go and look at the next characters, and it will subtract them. All right. Oh, they're the same. Let's go look at the next characters. And so, like, you've looked at these two compared against each other, and then you look at these two, the A versus the B, and you subtract them. It's going to subtract this one from this one. If this is your first argument, this is your second argument. And so, based on ASCII value math, it's going to be like, oh, okay, that's a negative value. I'm going to return that. And that's what it means. It comes before it. It's a little odd. So yeah, let's just show plenty of examples. Oops. Let's do it like this. String compare ABC to BCD. This is just like in line, I'm making C strings with those double quotes. So that one, let's do, so I'm going to get a negative value for that one. Let's do BCD versus ABC. I'm going to get a positive value because the first one's bigger. It comes after the dictionary. If they're equal, I'll get 0. And yeah, let's just start with this. So here's what I see. I got -1. I'm not guaranteed to get -1. It's probably because it was A versus B. Just any negative number means that the first one was smaller, came before it in the dictionary. Any positive number means that the word or the string came after in the dictionary is bigger, the first one. And then if you get 0, that means they're equal. Isn't that odd? So it is really just secretly doing ASCII math. And so hello versus hi mom is going to be a little weird. I guess it's still fine because it's not going to compare the space character. It's going to get to the I versus the E, right? And the E comes before the I, so technically it's going to say that the first one's smaller, and it'll give you a negative value. It's not guaranteed to always be -1, just some negative value. Okay? I hope that makes a little bit of sense. Yeah. So it comes after in the dictionary. That's what it means by greater string. Yeah. It is a little weird to wrap your mind around. So now if you want to check if your strings are equal, you can't do the double equality. You have to use string compare for C strings. You got to do something like if string compare S1, S2 is equal to 0. That is the kind of comparison you're going to have to do when you're working with C strings. You want to do something if they're the same. All right? Got to use a library function. Crazy. So yeah, I hope some of that makes sense. Just come back to this if you ever need to. But now let me explain why I'm actually teaching you C strings. All right, here's the thing. We are forced to use C strings right here. It's a thing called command line arguments. And it's very, very useful. So we've been running our programs like this. We've just compiled G++. We said // name of the program, hit enter. All right. But every other program that we've run, like the precompiled stuff that's been given to us, like G++, that's a program that somebody compiled somewhere, right? We've given things after the name G++. We've said, all right, give me a.cpp-o, a. If I use cd, that's just another program that somebody made. And I gave it things, cd tilde. And it did stuff with the stuff after the name of the program. So we want that ability, right? And it's called command line arguments, all right? We'd like to be able to run our program like this, /program, and then give it stuff, space-separated stuff, 42, high. And these are called command line arguments, essentially, because like you pretend that your program's name is a function, essentially. Pretend your program is a function. And it's like you're calling it, right? With like prog and high and, 42 first. 42 and high. Okay, that's kind of how that works. And so your program can actually see everything that's given to it in space-separated form on the terminal as a bunch of C strings. All right, that's the whole reason we're talking about them right now. It's very useful. The reason, or sorry, not the reason, the way that you can see your command line arguments and get that, it's going to be an array of C strings that you typed, is you can change the way you do main. All right, so there's actually two different ways to make a main function in C++. There's this one that we know, int main, and then you immediately just like open paren, close paren, and then you give your body. If you want access to your command line arguments, just like main is a function, they need to go in here. So we're going to put stuff in there, all right? So you can make your main like that, or you can make your main like this. It's still got to be int main. Here are the things that you will add if you want access to your command line arguments. You're going to say int argc char star for C string, right? argv bracket, and then you give your open curly brace and you do it as normal, right? So this is a little disgusting. These are just variable names, so you could call these other things, but people tend to call them argc and argv. Let me tell you what they mean. All right, so the first one is argc stands for your argument count. All right, so let me define that for you. I'll use rainbow. Argc means argument count. How many arguments were you given on the command line? It will count them for you and put it there, like the terminal does that for you. The terminal is kind of calling main arg count. And then this disgusting thing is an array of C strings. Let me try and prove that to you. So argv is an, well, the bracket, right? Let me color code it. The bracket means it's an array, right? It's an array. It's an array. Write that in a legible way. Do I have room? Kind of. It's an array of the thing that's on the left, right? Of whatever this type is. And we know what that type is, don't we? I'll use some other color. That means C string. It's an array of C strings, right? Of C strings. And the reason people call it argv, or they like to usually, is it's supposed to be short for argument vector. And I know that that is a bad name because it's just an array, but back in the day in C, there was no type called vector. This is brand new to C++. Don't blame them, it didn't exist yet. So that's the secret. So argv stands for argument vector. It's the actual array of the command line arguments that you got and gave as you press space as you're running your program. Okay, so that is a little weird. I'm going to give you an example right now, though. All right, so let's make a program that kind of works like this. That kind of gets our command line arguments and just prints them right back out so we can see what's going to happen. All right, so first of all, when you hook in to command line arguments like this, let me kind of give you an example of what argc and argv are going to be, what they're going to look like. All right, so your arguments, first of all, they're space separated. You can put as many spaces as you want, because remember, like if I did cd ... I don't have to use just one space. It'd be like cd space all the way over here ... and it still works. So it's chopping off any extra spaces. All right, that's the terminal doing that for us. But let's pretend we write a program, and it was called prog, and we want to run it like this. We say /prog, and then we space separate, like 1, 2, hi mom. Those are all space separated things with some amount of spaces. All right, what is going to happen when we hit enter. What is argc going to look like and argv going to look like? So, okay. If you were to run your program just like this, argc is going to count the command line arguments. And there are 5 of them. The name of the program counts. So 1, 2, 3, 4, 5. All right? So argc will be set to 5. You will see 5 if you look at it, if you run the program just like this. Okay? So argc is 5. It's going to count all those space-separated words for you. And then argv is the array of C strings of all those space-separated things with all the spaces chopped off. All right? So argv is going to look like this. It's an array of C strings. It's going to be ./prog first. That's what it's going to get. Then the string 1, the C string 1, it's not a number, it's just a C string right now. The C string 2, the C string high, and then the C string mom. Right? So it's the 5 things that you gave space separated on the terminal. The name of the program counts. Okay? Does that make sense? That's what's going to happen. That's what you're going to get if you use argc and argv. And if you ran the program differently, argc and argv will be different things. They're going to be set to whatever you just gave as you ran the program. Okay? That is the secret. And so argc is just the size of argv. That's all it is. This is an array of size 5. It's like, okay, yeah, that's how you know when it's over. Okay? So let's make a program that works kind of like this. So it just like takes in all of our command line arguments and it prints out argc's count, and then it goes into argv at all the places. Okay? That's what we're going to do right now. All right, so I need to make a main just like that. Cool. And line args, that's CPP. Alright, so instead of this kind of main, it's going to be main int argc char star argv bracket bracket. Crazy. So remember, argc is your argument count. It's the number of command line arguments that you got, including the name of the program. That counts. Alright? And then argv is going to be argument vector. It's just an array though. It is the contents of the command line arguments as C strings. So even if you did / name of the program hit 42, right? It's just going to give you that as a C string still. Everything's a C string. So it's really an array of C strings. That's how you read it. It's an array of C strings. Right? So when we run our program, let's print out argc. That's an easy thing to do. And let me show you how it changes each time. So if I just run it like this, just by itself, argc is 1. The name of the program is always going to be 1, right? It'll always be there. But if I start giving stuff like hi, space mom, now it's 3. Does that make sense? There's now 3 separate things. 3 space separated things, and the spaces don't matter. Could have been a bunch of spaces. Hi mom, more spaces, 42. It'll just chop those off. It's like, okay, you gave me 4 separate things. And that's what argc sees. It's going to count them all up and shove them all in argv. Right? So argv is going to be an array of all of the C strings that I gave with all the spaces chopped off. Right? All the separate things. So let's iterate, because argc is the count. It's the size of argv. Let's just iterate from 0 to argc minus 1. Let's iterate through argv. Right? This is a challenge in dissecting types, I guess. So for int I equals 0, that's the first thing always in an array. I goes until it's less than argc, right? That's every valid index. Argc is like the size. I equals plus. And then let me output what is at argv of I right now. So argv of I holds space and actually give the thing. Because if I go to argv of I, that's a C string, right? It's a C string. I'll get one of these bad boys out, and I can print that. So whatever it was, show it to me, and then new line. All right? So that, I do believe, should do it. Yeah. So I'm looping through them all. So now, let's recompile, and let's go back to this weird one. So I ran it in this way. Just like this. /command line args, hi mom 42. It saw. So there were 4 separate things, chopped off the spaces. Argv of 0, the first thing, was this guy. Argv of 1 was this guy. Argv of 2 is that one. And then 42 was the last thing. Okay? Any questions about that? So if you did hello, hi, whatever, it's like, now there's 3 things. Argc and argv are always going to be set to whatever you just gave, and it's different every time, right? Depending on what you just typed. That's how you can control your program before it even runs. Oh yeah, I already compiled it. And then it's running all this code, and just kind of the terminal is calling main for us with the right things. And what was my example? 1, 2, hi mom. 1, 2 with any number of spaces is happy, right? So there are 5 separate things I just gave. argc is set to 5, and argv of all those valid indices shows me those values. All right? They're C strings though, so it's a 1 C string. It's not actually a number right now. You need to convert with the A2I function if you need that. You need it as an int. Okay. Any other questions about this? It's pretty cool. Pretty nice, yeah. What's your question? Yeah, that's what I said, right? Yeah, that's what it's doing. It is printing out, these are called command line arguments, and it's gonna, I'm just looping through them all. It's weird, I know. Alright. So yeah, argv is that. If you run it like that, it's different every time, okay? So that's another way to give input to your program. Let's do an example that kind of uses that, and it'll give us some extra examples. So let's use command line arguments to draw a square. Let's make a program that takes input from the command line arguments. We'll be like /draw square, and then we'll give how big we want that square to be. So we'll draw like a 5 by 5 square if we give a 5 there. Okay, does that kind of make sense? That's what we're gonna do. What do I want to do? So, all right, if I want to run my program like this and like have a number right there, where is that number in terms of argv? Argv of what? If I want the user to call me like this with a number right there, I guess what should argc be? Argc should be blank. What's the blank? If I want to run the program just like this, and I expect something here, what should argc? What should I check argc to be? Ooh, I think we're confused. Okay, tell me why. How many arguments are here? How many different words? Yeah, I count 2, right? There's 1, there's 2. Does that make sense? So I want to see 2 things. I want argc to be exactly 2. Does that make sense now? Okay. In that case, all right, if I want to get the 5 out, because that's going to control how I draw this box or the square, it's going to be at argv of what? Holds that width. Yeah, I think I heard it. So this will be, right, it's always the name of the program is the first thing, the 0th thing, and then this will be at index 1. Good. So argv of 1 holds the width as a C string. Right? And so we're going to have to convert it, but that's going to be the start of it. Let's make that happen now. This is so exciting. It's just it's a cool new thing that you can do now. So let's make a new file called draw square. And let's see. So I want command line argument, so I'm going to say int argc char star argv bracket bracket. Disgusting, I know. And what I'd like to do with my argv of 1, right? I want argv of 1 to be something. I want to use it, right? That's my width. Int width is kind of like argv of 1. But it's not quite ready, right? Because argv of 1 is a C string. It's like the number, it's like the digit 4, the digit 2 as characters. If I want the number 42, I better convert this, all right? Give me the actual thing with the A2I function, A2I. I think the A stands for alphabetic things, alphabet to integer, kind of. That's how I think of it. And that lives in the cstd.lib library. So now I have the width in argv of 1, and I just want to use that to draw a box. So for int I equals 0, I is less than width, I plus plus. It's one of those good old nested loops that we know and love by now, yeah? Let's do j. It's just going to be a box, so it's the same amount. So a bunch of stars with stars on each line, break the line. And that should do it. So now if I run, if I say draw a square, oh, let me zoom out. If I say draw a square, 5, it finds the 5. Look at it. It gets the 5, it converts it to a number, holds it in the width variable, and then it uses that width variable to draw exactly that kind of box. If I say 3, it gets the 3. It was an arc v of 1. If I say draw a square of 4, it finds it. That's so cool. Are there any questions about how this is working? Does that make enough sense? Cool. What else? What else? We should be checking though, because what if you did this, like draw a square 4 high? That probably shouldn't be allowed, because like that high was useless. Yeah, we should check that. And then also an even worse problem is, what if I did this? What do you think is going to happen? There is nothing in arc v of 1. I'll actually get a runtime here. There's nothing there. I'm trying to go to an index that doesn't exist. So we better guard against that, because we don't want the user to see that if we can help it. So let's just make sure the user gave us the right number of arguments. So argc, it better be 2, right? Because that ensures I have index 1 available, and it's no more than that, no less. Okay, so argc better be 2. If it's anything different, I'm done. I am not happy. All right, so if argc is not equal to 2, let's just have an if statement up at the top. If argc is not 2, if I did not get 2 command line arguments, then we're going to yell at the user right now. Cout must run with a single number. And actually, because we get the name of the program, we kind of have the way, we get an arg v of 0, right? We get the name of the program with the / and everything. We have the way that the user ran this program. We have whatever name they called it. So we can actually tell them. We can yell at them, hey, here's how you should have run this program, usage. Just like whatever you gave, whatever name this program was, arg v of 0, that's whatever you called it with, right? Whatever you ran the program with. And then it should have just one number right after it, where n is a number. You're like, isn't that nice? Like, we can yell at them and we get the name of the program for free. Like, whatever they called it, we get to know it, because that was whatever was in arg v of 0. Because they could have called it something else. They could have been like -o square or something. It didn't have to be draw square, right? But we get it. We get whatever it was. That's really cool. And then also, we don't want to continue, right? Because then we'll get a say, we'll get a runtime error right here. Usually. And so let's stop the program. Stop the program. There's a couple ways to do it. There you can say return, like return 0 to stop it. Or you can return a non-zero number, because that means error code, kind of. So that'll work. You could also do, because we already included cstdlib, there's also an exit function that you could call. Exit with some code, could be 0, could be like 1 to indicate there was an error, whatever you want. But that is going to stop the program and not let it continue to this line where an issue would have occurred. Yeah. So yeah, let's try that. So now if I say draw a square without anything, I don't get any nasty errors other than me yelling at the user. It's their error now. It's their problem. So must run with a single number, and I just printed out the name of the program. There's draw a square, and this is how you should have run it, user. Isn't that cool? And then if I give too many things, like 2 and then high as well, it's like, no, it's still not right. You gave too many things this time. It's still not good. Let's remind you how to run it, and then try again. And then when they do it right, it lets it continue. Okay, so that's pretty nice. That's some error checking. Our users will thank us for that. Any questions about any of that? Yes, sir. That's right. Yeah, whatever it was, because that's going to go in arg 0, arg v of 0. You'll always get the very first thing. It's going to split it up by spaces, and the name of the program's in there. It's the very first thing. That's pretty cool. All right. If we are good, yeah, I think there's time for it. I just have a fun, longer example. Let me do this silly thing, and it'll just be good practice. Let me write a program for you that takes a bunch of command line arguments, and then it's going to spit them right back out, kind of how we did the first program. And we're going to output them right back out to the screen after doing the following things to those command line arguments. We're going to capitalize every single letter in every command line argument. And there's a CC type function for that, right? It's like 2 upper. And then we're also going to shift over every digit. If we ever see the 0 character, we're going to change it to the 1 character. If we ever see the 2 character, we're going to change it to the 3 character. All the way to, like, if we see 9, make it wrap around to 0, I guess. All right? So here's kind of what I want. I want to make a program that runs like this. Like, whatever the name was, /prog. If I say blah space like high 42, then what I would like to see printed, let's not count the name of the program. Let's look at just these guys, the real command line arguments, and let's spit them back out after capitalizing every letter. So blah, all caps blah, all caps high, and then every digit I want to shift over. It should be high 53. Okay, that's what I'd like to do. This is my silly extended example. All right. So let me show you how I'll think about this. So, oops, capitalize and shift is what I'll call it. And we are, of course, getting command arguments, bracket. And I like to use CC type eventually. What else do I want to do? I'll eventually use other things, but that's a good start. All right, so let's iterate through. Oh, sorry, you have a question first? No, it's just the name of a type. It's just like an int or something. You don't put a comma after when you declare a variable. You don't say int comma the name. Yeah, it's just the name of a type. It's a fancy name though. It's an extended name. All right, so we're running for in main right now. Somebody gave us some command line arguments, at least the name of the program. So let's iterate through all the args after the name of the program. So from argv1 onwards, and let's mess with it. So for int I equals 1, right? We're going to not consider the name of the program that's going in argv of 0. Let's start at argv of 1 onwards. I is less than argc, I plus plus. All right, so I got those bad boys, and what do I want to do? I would like to, I guess, mess with argc. Argv of I right now. Okay, that's going to be my goal. Relational comparison result. Why is that telling me that right there? I have no idea. Just pretend that's correct right now. I don't think there's an issue unless you see it. Yeah. Thank you. Thank you very much. Yeah, that's hard to notice. I had commas on the brain now. Thank you. That's better. Much better. All right, so I'm going to mess with argv of I. What do I want to do with each string I see? Each argv of I, because it's a separate string, right? I got one that's blah the first time, then it could be high 42. All right, let's figure it out. An easier way to like mess with it, because I would have to do this, right? If I want to mess with the 0th character of argv of I, it would look like this. That may be a little confusing to us right now. So let's just like put it in somewhere. Like argv of I, that's a C string. It's of this type. Let me just save it. Save it around. We'll call it char star s equals argv of I. Right? I'm allowed to do that. That's the type of each element. Give me a C string, call it s. All right? So that is my s now. I'll just use s to talk about the current command line argument string that I want to mess with. S is the current command line arg I want to work on. All right? That's my goal. So I'm going to do stuff with s now. And what will I do? Well, I want to go through every character of it, don't I? I want to go through every character, like the B, the L, the A, the H, the H, the I, the 4, the 0. Each one will have a chance at being s, right? I would like to process every character of s. And this is actually linked to the original command line argument. So as long as it's happy, we're good, right? I can mess with each of them. And I can treat this like the array of characters that it is. I can be like s of I, go change it to something else. I'm allowed to do that, right? Because it really is just an array of characters. I can treat it like one. So, okay, I want to process every single character of s, but I'm not actually sure how big s is. It could be some giant word. It could be my name. That's 6 letters long. It could have been hi, which is just two characters long. How big is my string? How many indices of s are there to work with? There's a library function for that, isn't there? So I am forced to use strlen, because that'll tell me how big that string was, and then I can go through every single character of it, not including the null terminator, because that just stays as it was. So I will include the C string library, because that gives me strlen. And that's going to give me all the valid indices of s now. So I'm going to iterate over every valid index of s now. So for int j starts at 0, j is less than the size of the string, right? So that's going to be strlen of s, j++. So it's just, we got a nested loop just naturally. Okay, let's not be afraid. So I want to mess with S now. What do I want to do with each character of S? Well, I'm working on each character, and S of J is my current character. Okay, J is my indices. J ranges over everything I can go and look at. So S of J is my current character. All right. And what do I want to do with each S of J? Well, I like to capitalize it. I'm finally at the character level. I want to capitalize every character with 2 upper, and then I want to shift over every digit. All right, so we can do the capitalization pretty easily. So S of J, whatever it was, replace it with itself, but uppercase. If it was lowercase. 2 upper will do that for us, and it'll just keep everything else the same if it was already uppercase or something different, like an exclamation point. So it's happy. So there's that. And then also, if S of J is a digit, first of all, this 2 upper did nothing to a digit, and I would like to shift it. Okay? Shift it over to the next digit. So how do I know if S of J is a digit? CC type also comes to my rescue. So let's go back to that. So just like we used 2 upper, there's also a isDigit function. You call it with a character, and it gives you back a bool, and I know none of those types are correct right now, but it's still going to work. So we're going to say isDigit or current character, and we'll just check if it was true or not. So if isDigit of S of J gives me back true, all right, I want to do something. Before I go any further, this is kind of redundant. There is never a need to check if it's equal to true, because remember that this call will get replaced with either true or false. Okay, it'll give me back, yes, it was true, or no, it wasn't. And the if statement runs its body if what it sees there is true, and so you can just read it like this. If isDigit SJ, if S of J is a digit. If that resulted in true, do what I want. Okay, so it's redundant to say equals equals true. I just want to tell you that, and I'll keep saying that. I didn't need to do it. All right, so what do I need to do? If it's a digit, how do I shift it over? This is a tricky thing. There's no library function for that. I have to hard code this myself. There is a secret, though. If you remember the arrangement of those characters in the ASCII table, do you remember that the numbers, where are they? They're up here, aren't they? Oh, they're there. There's the 0. It starts at ASCII number 48. 0 is 48, 1's 49. The 2 character is 50. The 3 character is 51. Do you see, using the ASCII code for the characters, if I just added 1 to it, that would make the correct other shifted character. If it was 0, adding 1 to it will give it the ASCII code for 1. If it was 1, adding 1 to its ASCII code will give me the ASCII code for 2. That's quite nice. The only thing this won't work on is 9. So we're going to have to fix that. But that's a good start at least. So, all right, shift it over by saying like S of J equals S of J plus 1. Add 1 to the ASCII code because the next digit is usually after it. Cool. Oops. So that is mostly the answer. All right. And then each time I've processed every character of S. By the time I'm done, by the time I'm here over with this for loop, this whole thing's over. S has been changed to what I wanted it to be, and then I can print it out. Okay, so this is quite large. Here's everything all at once. Let's take a look and see how good it does. This is a good one to study. It's just an extended example. So okay, I gave no command line argument, so it did nothing. But if I give blah high 42. Look at it go. It's making all caps blah and then high 53. Isn't that nice? Any questions about why this code's doing it? At least right now. Most of it. So there's still one issue. If I said high 49, I'm going to get high 5 colon, because apparently the colon character comes after the 9. That's not good. It needed to wrap around. We need to make this 0. Okay? So that's the last piece of the puzzle. And we just have to add another if statement. It's like, usually do this, but if it was a 9, do something different. All right, so if, now we have a nested if statement. Again, arising naturally from just what we noticed we needed. If S of J is the 9 character, then replace it with the 0 character. Otherwise, it's one of the other ones, and this trick works. Okay? I cannot hope to show you the entire code at once, so just like look at it when I post it. But like this is the relevant code that I've changed now. And if I recompile and rerun, I finally get the 9 wraps around to 0, so I get high 50. And everything else still works, right? 42, 429, cool. And yeah, remember that you can add as many spaces as you want, doesn't matter. That is a good example of going through all of our command line arguments, not including the name of the program, and just changing them up. All right, I think that is all that I wanted to say. Any last questions about that or anything else? My extended example of the day. It's a good one to study, though. All right, if we are good, that's the end of the slides. We made it to the end of arrays and vectors. We'll have a new topic next time. And yeah, there's no need to give you a new lab yet because I'm still I'm hoping that you're studying for the exam. And so I'm not going to give you a new one until the other one's due, which is a while from now. Or at least maybe next week I'll give you one, but if you want to get ahead. But yeah, this one is still not due for a while, so I'll just wait to give you your next one. All right? So yeah, that's all that I got for the day.